it into the bottom bin. All right. So, ladies and gentlemen, the unit vector is basically v over the magnitude of v. Easiest thing I think to do is just to find the magnitude of v first. So the magnitude of v, if you guys remember, is v1 squared plus v2 squared. So here is v1, here is v2. Right? Each vector I wrote up there before. Look at it. Even it's written right up there. A vector is broken up into v1 and v2. So v1 squared is negative 2 squared, which is 4, plus v2 squared, which is 16, which is 4 squared, which is 16. So that equals the square root of 20. And you can reduce the square root of 20 into square root of 4 times 10, which is 2 square root, 4 times 5. 2 square root of 5. Would everybody agree with me? OK, so now I just take my vector v, which is negative 2, 4, divided by 2 square root of 5. Well, now what do you do? Well, guys, if I said k times if I said k times v1 comma v2 was equal to k v1 comma k v2, everybody agreed with that, right? Yes? OK, well, let me ask you another question. Do you guys agree with me? 4 divided by 2 is the same thing as 1/2 times 4? That's the same thing. So in reality, all you're doing is multiplying. Do you guys agree with me? These are the same thing. You're writing a division problem as a multiplication problem. Does that make sense? Yes?
I thought if they went in the same direction, the magnitude is 1.
Huh?
I thought if they went in the same direction, the magnitude is 1.
No, the magnitude is always going to be 1 for unit vectors. What I'm saying is the original vector v and our unit vector are going to go in the same direction.
So isn't the magnitude still 1?
Magnitude will be 1. Just hold on, I'm not done yet. Yes?
So this end is going to turn out to be 1?
No. The magnitude of it will be 1. Let's find the unit vector first, and then I'll show you guys how to prove it right. So now I basically have a vector negative 2 over 2 square root of 5, comma, 4 over 2 square root of 5. Can I simplify this? A lot of times we don't like to rationalize the denominator with vectors. I have no problem if you do that. But vectors, it's not very common for us to rationalize the denominator, so we just leave them. It's not really going to really help us. So we just leave it like this. OK? So you can leave it like that. However, please note that a book or a test might rationalize the denominator to put it in a different format. All right?